Alright, this is going to be a quick video, or hopefully a quick video, of how to graph a standard form parabola. Notice up top on the screen here we've got what we call a standard form parabola. We have our x squared, our x to the first, and our constant. The first thing that we're going to identify is what are the a, b, and c. Again, if we're talking about standard form, we're talking about a parabola or a graph that's going to have y equal to ax squared plus bx plus c. So a is the coefficient of x squared, so right now that's going to be a 1. B is the coefficient of x, so -2. And c finally is the constant term over here at the end, or that -3. So if we have those three things identified, that's going to be very helpful for us here at the top. Mostly because those three things tell us a lot about our graph. Remember, we'll know whether or not our parabola is going to open upwards or downwards, depending on whether or not a is positive or negative. If a is a positive 1, we know that our parabola is going to open upwards. Okay? It's going to open up. It's going to be a U shape traveling upwards, or something like this. Okay? That kind of a shape. Secondly, to find the axis of symmetry, remember we have a nice shortcut. X equals -b over 2a. We've talked about that previously. So again, the x equals -b over 2a. If I grab -b, now 2 is already negative, so negative of -2 is going to be positive 2. Divided by 2 times a, 2 times 1. We can set that up, and we'll have -b over 2a is negative of -2 over 2 times 1. 2 over 2 is 1, and remember that that technically is x equals. So again, that equation of our axis of symmetry, if we head over here to our graph, we can graph a line at x equals 1, right, along here, okay, where we know that that's going to be the center of our graph. Left to right, that's going to be the middle of our graph. If we take that 1, then plug it into our formula, right, 1 squared minus 2 times 1 minus 3, we can find the y-coordinate of our vertex, and thus overall know that our vertex is going to be 1, -4. 1, -4, right here on our graph, let me go ahead and change colors there, is our vertex. After that, we just need some more points, and again, that axis of symmetry is very helpful. We want points near that axis of symmetry. Plugging in things like 0 is often very helpful, especially since 0 is right next to our axis of symmetry right now. And not to mention that 0 squared is 0, minus 2 times 0, which is 0. 0 minus 0 minus 3, I believe if you check that 0 in there, that 0, -3 will be a point on our graph. So we can identify that. Now, you can plug lots of other points in and continue to find coordinates, such as -1. You can plug that in, and I believe you'll get back 0. Again, I'll leave you to kind of do those calculations, but I'm fairly confident we'll get that point there. Notice, if you do know the shortcut, 1, 3, 5, 7, from our vertex, I went up 1, then we went up 3. I believe our next point will be up 5. And if we use our axis of symmetry, we can reflect those points across our axis of symmetry. Okay, 3 points to the left of our blue line, 3 points to the right of our blue line, and now we can make as smooth a parabola as possible. Now I apologize, I'm not very quickly or not very smooth on this computer, so this is going to look a little wiggly more than likely, but try to make as smooth a line as we can out of those points. Hopefully your parabola looks a little bit better than mine. Don't forget to label your graph as well. We counted by 1s in both directions. Now I could label my axis of symmetry, which would be a good idea, x equals 1. Or I could just go out here and say, hey, that's a 10, because I counted by 1s. I also want to label my y-axis. So notice I can again label that as 1, or we could have labeled the fact that we're up at 5, or that your vertex was down at -4. Any label on that y-axis is going to be a helpful label. Let's take another look at another standard form equation. Go ahead and pause the video now. I'm going to fill in the information, and we'll see if you come up with the same graph that I did. Alright, welcome back. I've gone ahead and filled in a lot of the information here, so let's walk through it very quickly. And again, if your information looks good, you can always scroll forward and take a look at some more of these notes. First of all, I noticed that a was 3, which means that's greater than 0, and I know this parabola is going to open upwards. So I like the fact that my final answer ended up going upwards. The axis of symmetry, negative b over 2a, came out to x equals 1. So again, I've got that dashed line drawing my axis of symmetry. I plugged that 1 back into my equation, and you'll notice I ended up with 6. So I plotted my point at 1, 6. Now I know that 6 and opening upward aren't a great combination on my graph, because that means I'm going to go up fairly quickly. So I went ahead and counted by 3s. Notice the label on my y-axis here. I went and counted by 3s so that this is 1, 6 right here. In that case, I also found a couple more points. Since 0, 9 is on my graph, I know that's 1 unit from my axis of symmetry, so I went 1 unit to the right as well and plotted a point at 2, 9. Then I also plugged in 3 and figured out I'm up at 18. So notice again, counting by 3s, that's 3, 18 up here on my graph, which also means, again, I'm 2 points from my axis of symmetry, 2 lines away. So I did 2 lines to the left over here at negative 1. I'm also up at 18. And then finally, I tried to draw as smooth a line as I could. Don't forget the arrows on the end to tell me my graph keeps going. And there's my graph. Again, some important information about standard form equations is given to you right here. A standard form equation looks like y equals ax squared plus bx plus c. Your graph will open upwards, like the graph over here at the right. If a is greater than 0, it's going to open downwards if a is less than 0. Again, that has to do with that vertical reflection idea. If it's a negative x squared, we've reflected it. We're going to open downwards on our parabola, or on our graph. If a is large, we're going to have a fairly narrow graph, right? If a is small, somewhere between 0 and 1, we're going to have a fairly wide graph. Again, that goes back to that vertically shrinking and stretching idea. The larger that a is, the faster we go upwards, kind of like that last graph we did when a was 3. It went up very quickly, so I had to count by a larger number. I wasn't even going to fit that on my graph. Vertically shrinking, though, if that was less than 1, if we're between 0 and 1, then our graph would have been much wider. Right, a much wider graph. The vertex, again, we can use negative b over 2a to help us find that x-coordinate, which is also, again, our axis of symmetry. Right? And then, of course, plug that back in to get our y-coordinate. The y-intercept is also fairly easy to find. If you plug in 0 for x, we did that on a couple of those graphs, c will end up being our y-intercept. Sometimes a really easy point to find and a really easy point to reflect over that axis of symmetry to get another point off to the right side or the left side. Let's do one more example very quickly here. I'm going to, again, pause the video. Feel free to fill in all this information, get yourself a good-looking graph, and then in just a second, I'll show you the answer. You can check your answers. All right, here we go. One last little run-through. You'll notice again that a was a negative 1, which means we're opening downwards. I plugged my negative b over 2a into my formula, ended up with x equals negative 1. Plug negative 1 back into my formula down here near the bottom, and y ended up equal to 9. So I plotted the points negative 1, 9. Now I know that I'm opening downwards, so I'm not worried about space. So I just went ahead and counted by 1s in both directions. To get more points, again, I plugged in 0, which got me back an 8, which also meant that at negative 2, I would also be up at 8, using that symmetry idea again, right around that x equals negative 1. It's really important we find the correct axis of symmetry, so that we can have a lot of easy to find points. Again, now that I've got all that information on there, I drew a smooth line, and as you notice, as the video even went along, the more I graph those parabolas, the smoother they're getting. Still not quite perfect, but I'm working on it. Again, take your time when you're doing this. Make sure, again, you identify that axis, identify that vertex, and find a few additional points. Help yourself kind of graph that out. If you're familiar with that 1, 3, 5, 7 method, notice this time with a negative 1 for an a value, we went from the vertex down 1, down 3, down 5, because I know I'm opening downwards on my graph. If you have any other questions, make sure you talk to your teacher. Otherwise, good luck and happy parabolas.